Next example on the function, topic function. Let x is the set minus 2, minus 1, 0, 1, 2. And let the function f from x to r, that is x is domain and r means set of all real numbers is codomain. We define by this formula fx is equal to x square plus 1. And the question is find the range of f. That is, what is the range of the function? Range of the function is the set of all images. Okay, so first count the image of each element of this set x. This set x contains total 5 elements. Now we have to find first image under this function fx is equal to x square plus 1 of each element. So f of minus 2. How we can find f of minus 2? Substitute x as a minus 2. So minus 2 square plus 1, that is 5. That is 5 is the image of minus 2. Then f of minus 1. The image of minus 1 is what? Minus 1 square plus 1, that is 2. Then f of 0, that is a 0 square plus 1, that is 1. Then f of 1, that is image of 1 under f, is 1 square plus 1, 2. And f of 2 is what? 2 square plus 1, that is 5. And then what is the range of the function f? Is the set. Is denoted by the notation rf, capital R in bracket f. F is the notation for the function. So write r in bracket f is equal to the set of all images. So under this function we have the image 5 of minus 2, then 2 is the image of minus 1, then 1 is the image of 0, and again 2 is the image of 1. In this set 2 already written in this place, therefore no need to write 2 double twice. Then 5 is also in this set. So this is the set 5 to 1, set of all images. That x contains 5 elements, but images, set of image contains 3 elements because the image of 2 elements are same. And so this is the range of the function or set of images. So next example, let x is minus 2 to 2. That is the closed interval minus 2 to 2. So what is this meaning of this interval? This set contains, this interval minus 2 to 2 contains all numbers lies between minus 2 and 2. So how many numbers lies between minus 2 and 2? There are infinitely many numbers lies between minus 2 and 2. So what are that? For example, minus 1.99, then minus 1.6, minus 1.5, minus 1.54, minus 1.50, then minus 1. Also number lies between these two. Then minus 1 and then 0. The numbers lies between minus 1 and 0 are what? Minus 0.5, minus 0.6, minus 0.71, all these numbers. Then 0 also the element of this set x. Then 0 and then 1. Okay, and between 0 and 1, what are the numbers? 0.1, 0.11, 0.12, 0.13, 0.22, all these. Then 1, 1.5, 1.6, 1.1, up to 1 point, up to 2. Not up to 2, but also at the 2 is also member of this set. So what is this closed interval minus 2? This is the set of all elements lies between minus 2 and 2. Also minus 2 and 2 are the members of this set x. That is, what is the number the members of this set x, elements of this set minus 2, 2, and all numbers lies between minus 2 and 2. Between minus 2 and 2, there are 3 integers, that is minus 1, then 0 and 1. Okay, there are 3 integers, but how many numbers lie between minus 2 and 2? Minus 2 and 2, between minus 2 and 2, there are infinitely many numbers. And this is the domain of the function. In the previous example, domain of the function is x, but x contains only 5 elements. But in this example, what is the domain? Domain is the closed set minus 2, 2. And this set contains how many elements? This set contains minus 2, 2, and all numbers lie between minus 2 and 2. And that is, this set x contains infinitely many numbers. And y is this set 1, 5. And the function f from x to r is defined by this notation, definition, fx is equal to x square. And g is the function from y to r, another function. defined by gy is equal to y square. And is f injective? Question is what? F is f injective? So when the and another question is g is injective? So when the function is injective, if the elements are different in the domain, that is if there are two different, if you take any two different elements from this x, and if their images are also different, then the function is injective. But if you have at least two elements in this domain, that is if you have two elements in this set x such that their images are same under this function, then function is not injective. And what is the this set contains what are the elements of this set? Minus 2 is the element of this set, 2 is the element of this set. Also all numbers lies between minus 2 and 2, that is minus 1 is the element of this set, also 1 is the element of this set. So if you take f of minus 2, then it is 4, and if we take find f of 2, that is image of 2, then it is also 4, and therefore but minus 2 and 2 are the different elements. Or we can also give on the reason that minus 1 and plus 1 also the elements of this set, and therefore f of minus 1 is 1, f of 1 is 1. So elements are different but their images are same, and so f is not injective. Also we can give the counter example. This example it's called counter example, that is the condition fails for this element. We also give the example that f of minus 1.5 and f of 1.5 both are same. And we also give the example that f of minus 0.2 and f of plus 0.2 both are same. So there are infinitely many counter examples to justify that f is not injective. Just give any one example, it's called counter example, that is the condition fails for that two elements. Okay, that is the elements are different but the images are same. Okay, and therefore f is not injective. Such an example is called counter example. By using counter example we justify that f is not injective. Okay, so and g is also, what is the g? G is injective here, because why g is injective? The definition is same, gy is equal to y square, but the domain is different. Domain is what? 1, 5. And under this function again, my image of minus 2 is 4, also image of plus 2 is 4, also image of under this function g, image of minus 1 and image of plus 1 both are same, but the elements are not members of this set y, this domain. When the function is not injective, if we have two elements in the domain, that is if we have two elements in y such that the elements are different but their images are same. So under this function gy is equal to y square, image of minus 2 and plus 2 are same, but minus 2 and plus 2 are not element of this set 1, 5. So if we consider any two elements from y, all the elements what is the y set y? This set y contains close interval 1, 5, means contains 1, 5 and all elements lie between 1 and 5. That is all elements, fractional elements and elements, integers. What are the integers lies between 1 and 5? 2, 3, 4 and all the numbers. This set contains also 1.1, 1.5, 1.6, 1.7, 1.8, all the elements up to 5 lies between. What are the elements of this set y? 1, 5 are the elements of y, and all numbers, not just integers, all numbers lies between 1 and 5. But if you take any two elements, different elements from y, that is domain under this function g, but what are their images? If you take suppose 1 and 5, what is the image of 1? Image of 1 is 1 and image of 5 is 25. That is elements are different, their images are also different. Or if you take any two elements from this set, suppose we take 2 and 3 from this set, 2 and 3, then what we have? Image of 2 is 4, image of 3 is 9. That is elements are different and images are also different under this function g, and therefore g is a injective. Okay, because this set contains, domain contains positive elements, and squares of distinct positive numbers are distinct. Squares of positive and negative, some positive and negative numbers are same, but the squares of distinct positive integers, that is if the integers are distinct and positive, then their squares are also distinct, and that's why this function g, the definition is same. The definition of function f and g both are same. but the domain of the function f and g are different, and that's why one function f becomes not injective while g becomes injective. That is, the injectiveness or surjectiveness depends on the function as well as domain. Depends on the function, definition of function as well as domain. The definitions are same, but one function is injective, other is not injective, because the domains are also different in these two examples. So the domains are also important for the function to be injective or to be surjective. Next example, f is function from R to R, g is function from R to R, and the definitions are given. 1 plus sin x fx is equal to, and gx is x square. Then find g circle f and f circle g. So this example is important. Such a type of examples are important as far as the exam concerned. So g circle fx is what? G of fx. This is the formula to find for g circle fx. So g circle fx is what? G of fx, and fx is 1 plus sin x, and gx is x square. So g of 1 plus sin x is what? 1 plus sin x square. So its square is this, and this is the formula for g circle f. Then formula for f circle g is what? F circle gx, or write f into gx is equal to f of gx. Right here circle, notation circle or dot. Okay. And then what is its definition? F of gx. F circle gx is what? F of gx, and gx is x square. And what is fx? Fx is 1 plus sin x. What is fy? 1 plus sin y. Like that. What is f of x square? 1 plus sin x square. So this is the formula for f circle g. And if you observe g circle f and f circle g, these two are different, and therefore the composition of two function is not commutative. The commutative law does not true for composition of two functions. So what is the commutative law? For example, the commutative law is true for multiplication of numbers. That is 2 into 3 and 3 into 2 both are same. While addition is commutative, addition of numbers. 2 plus 3 and 3 plus 2 both are same. But subtraction is not commutative. 2 minus 3 and 3 minus 2 are different. Okay, like that, this composition of two function is not commutative. This is the counter example to justify the composition of two function is not commutative. The next example, f is function from x to r defined by fx is equal to x square minus x minus 2, and x is this set, that is the domain of the set is what? It contains these 5 elements. Find range of the function. So right, range of the function notation is what? Fx or capital R in round bracket f is equal to the set of all images. So image of -1, image of 0, that is f of 0, f of 2, f of 5, f of 11, right? In curly bracket, because it is set. So in curly bracket, f of -1 is what? Is substitute x as a -1. So -1 square is +1, -1, 0, becomes answer 0. Okay. So -1 square is +1, and then -1 becomes become what? +1 -1 becomes, here is substitute x as -1. -1 square is +1, minus +1. That is +1 +1 2, -2 becomes 0. Then f of 0, 0 square minus 0 minus 2, answer is -2. Then f of 2, f of 2 is what again? F of 2 is 0. So no need to write 0 two times, right? Then element image of 5, that is 18, and image of 11 by substituting x is equal to 11, we get 108 answer. This is the range of the function, right? F of x or rf, r in bracket f, capital R in bracket f, range of this function, that is the set of all images. Then this is the definition of bijective functions. The function which is both injective and surjective is called bijective. And the examples of bijective functions is this function is bijective. Okay, so this function is both injective and surjective, that's why the function is bijective. So the important question on this bijective function is what? Let f from R to R be function defined by fx is equal to 3x plus 2 for all x belongs to R, that is the real valued function. Then show that f is bijective. So then F is bijective function. So what is the answer of this problem? First, show the function is injective. So I can show the function is injective. The function is injective if x1 is not equal to x2 in R, that is in domain. Then if we have f of x1 is not equal to f of x2, that is if the elements are different and if we have the images are also different, then the function is injective. So take two elements from this domain and codomain in this example. In this function, domain and codomain both are same. So take two elements, suppose x1 and x2, or take x and y. Either take x1 and x2 or x and y, such that they are different, not equal. And now we have to show f of x1 is not equal to f of x2. So what is f of x1? 3x1 plus 2. And what is f of x2? 3x2 plus 2. That is, we have to show this 3x1 plus 2 is not equal to 3x2 plus 2. So multiply this x1 and x2 by both sides by 3, then not equal sign continue. X1 is not equal to x2, then 3x1 is also not equal to x2, and then we have add 2 on both sides. Then we have 3x1 plus 2 is not equal to. So here is correction, right? Not equal to sign. There is not equal to sign. So right here not equal to 3x2 plus 2. That is add 2 on both sides. And therefore what we have is this 3x1 plus 2 means f of x1, and the 3x2 plus 2 means f of x2. So f of x1 is not equal to f of x2, and therefore the function f is injective. Why the function f is injective? Because we have, if the elements are different in domain, then their images f of x1 and f of x2 are also different in the codomain, and therefore the function is injective. Now we show the function is surjective, that is onto. And for that, if when the function is onto surjective, if every element of codomain, has at least one pre-image, then function is surjective. Okay, if we have some element or at least one element in codomain which has no pre-image, then we say the function is not surjective. For example, this is the example of what? Not surjective. Why is not surjective? Because this one is the element of codomain in this function g, but it has no pre-image. Then the function is surjective if every element has at least one pre-image. This function f is also not surjective. This function h is surjective. Why surjective? Because its codomain contains only two elements, 1 and 2, and both elements has at least one pre-image. What is the pre-image of 1? Is A. What is the pre-image of 2? 2 has two pre-images. So when the function is surjective, if each element of codomain has at least one pre-image, that is, some elements may have the more than one pre-images. So when the function is not surjective, if there is element in codomain which has no pre-image, like this function, so this h and f1 both are surjective functions. Now how we can show the function is surjective? Show the function is surjective if every element of codomain has pre-image. So this R in this set R, that is in codomain of this function f, contains infinitely many elements. The codomain of this function f contains infinitely many elements. And now we have to show the property for each element. And so how we can show the property for infinitely many elements? We take any one element out of that infinitely many elements and show the property is satisfied for that element, and then we say the property is satisfied for all elements. So this is the procedure if the elements are infinitely many. If the elements in this codomain are suppose finite or small in number, for example, this example, how many numbers lies in codomain of this function here? There are 4 elements. And so how we can check this function is surjective or not surjective? By taking one by one element from the codomain, that is, take one and observe that one has pre-image or one has no pre-image. Then take 2, observe it has pre-image or no pre-image. Like that, one by one, if the elements are finite in number, then we can check the property by taking the elements from that set one by one. But if the elements in the codomain are infinitely many and we have to check the property for each element, then what is our procedure? any property, not only subjective condition, injective conditions, any property, if I have to check some for some large number of elements or infinitely many number of elements, then what is the procedure? Take any one element out of that infinitely many elements, or uh, from that infinitely many elements, take any arbitrary element and check the property for that element. And if the property is satisfied for that element, we say that the property is satisfied for all elements. And if the property is not satisfied for that element, then we say the property dissatisfied for the element. Because when the property satisfied for the elements, if the for the set, if the property is satisfied for every element or each element of the set. But when the property, we say when the function is not surjective, if we have at least one element in a codomain which has no preimage. So if we take some, suppose in a arbitrary element from this set, and if the property is dissatisfied for that element, then we say the property is dissatisfied for the function for that set. Because when the property is dissatisfied, if the property is dissatisfied for at least one element, so our procedure is what? Take any element from this codomain, let y belongs to R, be any real number, be any element of this set R. Then now we have to find its pre-image. Suppose x is the pre-image of y. Suppose x is the pre-image of y. That is, we take the equation fx is equal to y. And then what is fx? 3x. Now we have to find the value of x. We have to find the pre-image of y, means we have to find the value of x, because here we take x as a pre-image. Then this equation fx is equal to y implies fx is what? 3x plus 2 is equal to y. And this equation has unique solution. X is equal to what? Shift these 2 is minus 2 divided by 3. So what we have the value of x? Y minus 3, y minus 2 by 3. And if we find f of y minus 2, if we find fx means f of y minus 2 by 3, by using this definition, substitute x as a y minus 2 by 3. Substitute here x as y minus 2 by 3. 3 get cancelled, and x minus 2 plus 2 becomes x, y. 3, substitute x as y minus 2 by 3 plus 2. We have the answer y. That is fx is equal to y. That is, this y minus 2 by 3 is pre-image of y. Okay, what is the sentence? Therefore, x is equal to y minus 3 is such that fx is equal to y, or x y minus 2 by 3 is pre-image of y. And therefore, the function f is surjective, because this y is arbitrary element of this set R, and it has pre-image. Therefore, every element of this codomain has pre-images, and therefore the function is surjective, and hence the function is bijective, because the function is injective as well as surjective. Same example, here is the same example. Let f from R to R be defined by fx is equal to 3x minus 4. Show that f is bijective, and hence find f inverse. After definition of inverse function, we will solve this next sentence, next problem. So just here we now show the function is bijective. So first we have to show the function is injective. Take two x1 and x2 element of this domain such that x1 is not equal to x2. Then what happen? Multiply both sides by 3. Then 3x1 is not equal to 3x2, and then 3x1 minus 4 is not equal to 3x2 minus 4. And therefore f of x1, this is f of x1, 3x1 minus 4. This is f of x2. F of x1 is not equal to f of x2, and this shows that f is injective. So when the function is injective, we know the definition of the injective function. This is the definition of injective function. When the function is not injective, if for every x and y belongs to x, if x is not equal to y, and then if you have f of x1 is not equal to f of fy, this condition is satisfied by the elements, all the elements of the domain, then function is not injective. That is, elements are different, and if the eliminations are also different, then the function is injective. So here x1 and x2 are the elements of this domain, and these two are different, and then we have f of x1 is also not equal to f of x2. And how we can show this? That is, if x1 is not x2, then 3x1 is not equal to 3x2, and 3x1 minus 4 is then not equal to 3x2 minus 4, that is f of x1 is not equal to f of x2. This shows that f is injective. Then next part is what? Surjective. So for how can show the function is surjective? This codomain contains infinitely many elements to take any y belongs to R. And suppose that fx is equal to y. That is, we assume that x is the pre-image of y. And then write fx as 3x minus 4 and solve this equation for x. Then x is what? Y plus 4 by 3. And this is the pre-image of the function. If you find fx, that is f of y plus 4 by 3, then 3, by using this difference, 3 y plus 4 by 3 minus 4, we have the answer y. That is, y plus 4 by 3 is the pre-image of y. And this y, that is, y has pre-image, and hence f is surjective, and therefore f is bijective function because it is both injective and surjective. Similar example is here, show that g function is bijective. Instead of f, the notation is g. So take x1 and x2, these two are not equal from this. This is the another proof. Give the proof of this injective condition similar to this condition, this problem. That is, take x1 and x2 not equal, then write 5x1 is not equal to 5x2, then write 5x1 is not equal to 5x1 minus 2 is not equal to 5x2 minus 2, and therefore gx1 is not equal to gx2. So write the proof of injective part, then surjective part. Let y be arbitrary element from this set R, and then we have to find the pre-image. Let x be the pre-image of this y under g, that is gx is equal to y. Then write, here is not the notation, yep, here is the right g, y is equal to gx implies, what is gx? 5x minus 2 gx, and then find x as y plus 2 by 5. And if you find f of y plus 2, g of y plus 2 by 5, similar to this, f of x means f of y plus 2 by 5, then we have the answer y. And therefore this y plus 2 by 5 is the pre-image of this y, and therefore every element of this set R has pre-image, and therefore the function g is surjective. Now we have to define the inverse of function. What is the inverse of function? If the function x to y is bijective, then its inverse is. So when the inverse of the function exists, if the function is bijective, if the function is not bijective, then we cannot find the inverse of the function. Like matrix in 12th standard, we observe that when the matrix inverse exists, if the matrix is non-singular, that is the determinant of matrix is not equal to 0, then its inverse exists. When the inverse of a number exists, if the number is not equal to 0, then inverse of number exists. Inverse of 0 does not exist. What is the inverse of 2? Number 2 is 1/2. What is the inverse of 2 by 3? Is 3 by 2. But why inverse of 2 by 3 is 3 by 2? Because 2 by 3 into 3 by 2 is equal to 1. Okay, so that is the meaning of the inverse of number. Inverse of number means if the multiplication of two number is 1, then they are inverses of each other. So 2 by 3 inverse is 3 by 2, because 2 by 3 into 3 by 2 is 1. Then what is the inverse of 1/2? Is 2, because 1/2 into 2 is 1. But what is the inverse of 0? It is not equal to 1 by 0, because 1 by 0 is not number. 1 by 0 is infinity, but infinity is not number. And we know that 0 into infinity is not equal to 0. It is not equal to 1. So inverse of 0 does not exist. Like that, that is when the inverse of number exists, if the number is non-zero. When the inverse of matrix exists, if the matrix is non-singular. Like that, when the inverse of function exists, we cannot find the inverse of every function. When we can find inverse of the function, if the function is bijective, then the inverse of function exists. So this is the necessary condition. To exist the inverse of the function is bijective, that is injective and surjective. Okay, and what is its notation for f inverse? F raised to minus 1, and is the function from y to x. The function inverse of the function is what? If f is function from x to y, then its inverse is denoted by f raised to minus 1 and is function from y to x, and is defined by if fx is equal to y, if fx is equal to y, then F inverse Y is X. F inverse Y is X. So this is the definition of the function. That is Fx is Y, then F inverse Y is X. That is Y, if Y is the image of X under F, then X is the image of Y under F inverse. Okay, under F in F, X is pre-image of Y, but under F inverse, X is image of Y. That is if image of 3 is 6 under F, then image of 6 under F inverse is 3. Okay, so this is the definition of F inverse. So here is the function in problem 1.30. This F is bijective function. Already we solved this example that F is bijective. Hence find F inverse. Hence F inverse. Find F inverse if exists. So F inverse exists because the function is bijective. So how we can define F inverse? F inverse Y is X. What is the definition? This is the definition. F inverse Y is X. So this is the formula. This is the definition to obtain the formula for F inverse. So Fx is Y, then F inverse Y is X. What is X? X is this, Y plus 4 by 3. And therefore F inverse Y is equal to Y plus 4 by 3. This is the formula that defines inverse of the function, F inverse. F inverse Y is equal to Y plus 4 by 3. This Y is the dummy variable. That's why you can replace this Y by X or Z or W. So if you replace a Y by X, then F inverse X is equal to X plus 4 by 3. Right? Either this is final answer or this is final answer. That F inverse Y is equal to Y plus 4 by 3. This is what? The inverse of the function F inverse. Okay. So how we can find the F inverse? Inverse of the function. When we find F inverse, if the function is bijective. And how we can find the F inverse of the function? F inverse, take F inverse Y is equal to X as the equation formula. Then X as this value, Y plus 4 by 3. Similar example here, find G inverse, formula for G inverse. So G inverse is what? G inverse Y is equal to X. So G inverse Y is equal to X. F inverse Y is equal to X. Here is the notation G. Therefore, take G inverse Y is equal to X. And what is X? X is this, Y plus 2 by 5. So G inverse Y is Y plus 2 by 5. Or write instead of Y as X notation, dummy notation, that is G inverse X is equal to, right here is equal to X plus 2 by 5. This is the formula that defines F inverse. So one more theorem on this topic, that F from X to Y and G from Y to Z be bijective functions. Then show that their multiplication, that is their composition, G circle F from X to Z is also bijective. That is what is given. This function F and G are bijective, and we have to show this function composition G circle F from X to Z is bijective. So we have to show this function is bijective. So when this function is bijective, G circle F from X to Z, if x1 and x2 are not equal in this X, suppose x1 and x2 are in X, such that x1 is not equal to x2. And if we have G circle Fx1 is not equal to G circle Fx2, then this function becomes injective. So take two elements from this set X, write here notation xy or x1, x2 in X, this set X, such that x1 is not equal to x2. Now we have to show G circle Fx1 is not equal to G circle Fx2. So x1 is not equal to x2, and this function x2y, this function F from x to y is bijective, means this function is injective. This function F is injective, and therefore F of x1 is not equal to F of x2, because since F is what? Injective. And therefore x1 is not equal to x2, therefore we have F of x1 is not equal to F of x2, because given that F is bijective, G is bijective, means F and G both are injective as well as surjective. And F is injective, and x1 and x2 are the element of this set X, therefore their images under this function F in Y, that is F of x1, is not equal to F of x2, since F is injective. And then the image, these two are not equal, F of x1 is not equal to F of x2, and these are the elements of Y, this Y, and therefore their images under G, that is G in bracket F of x1 is not equal to g in bracket f of x2, because either right here the question, the reason that g is injective, as g is injective, we have this, and these two elements are different in y, and therefore their images under G are also different because G is injective, and therefore G of fx by f of x1 implies what is the another notation, G circle fx1 by using definition of composition of two functions. G f of x1 is what, G circle fx1, and this is G circle fx2. These two are not equal, and therefore what do we have? If x1 and x2 not equal in x, then G circle fx1 and G circle fx2 in Z are not equal. That is, under this function G circle f, x1, images of x1 and x2 are not equal. If the elements are different, images under G circle f are not equal, and therefore G circle f is an injective function. Now we show that G circle f is surjective. So when the function is surjective, if each element of this codomain, that is if each element of Z has free images, so take any element Z from Z, be any element, and now we have to find the free image of Z under G circle f. So as a Z is here, the small z is the element of Z, and as G is surjective because G is bijective, and therefore this Z in Z has free image in Y, some element free image in Y. Suppose as here Z is G is surjective function, for Z in Y there exists its free image under this function G. Suppose Y is the free image of this Z under the G, that is Gy is equal to Z. As G is surjective function, for Z belongs to Z, there exists at least one element. Suppose Y is our notation, Y in Y, such that Gy is equal to Z. It has free image. Z is the element of Z, and G is in surjective. Therefore, each element of Z has free image, and therefore the Z has free image. We know, and what is its free image? Denoted by Y. Y is our notation. So Y is the free image. Suppose Y is the free image of Z, that is Gy is equal to Z. Under G, the image of Y is Z. Again, this Gy, now this Gy becomes element of what? Gy becomes element of Y, that is this Y. And this function f is bijective, means is surjective, and therefore every element of Y has free images. And now this Gy has free image. And suppose X is the free image of this Gy. X is the free image of this Gy. That is, we take that G of f of x is equal to f of Gy is equal to, here is, we take X as the free image of this Gy. That is f of x is equal to Y, because Y is not Gy, Y is the element of this Y. Y is the element of this Y. Okay, because Y is the free image, Y is the element of Y, and Y is the element of this Y, means Y has free image. And suppose X is the free image of this Y, that is fx is equal to Y, because f is surjective, every element of Y has free image, and therefore this Y is the element of Y has free image. So we denote the free image of Y by X notation. So X is the element of X such that fx is equal to Y. And then find G circle fx is what? G of fx, and fx is Y and Gy is Z. So what do we have? This X is the free image of the Z under G circle f, and therefore the function G circle f is surjective function. For any Z belongs to Z, there exists X in X such that G circle f x is equal to Z. That is, for the Z we have free image which is X in X such that G circle f x is equal to Z, and so G circle f is a surjective function. So G circle f is injective function, G circle f is surjective function, and therefore G circle f is a bijective function. That is, if f and G are bijective, then their composition is also a bijective function. So these are some examples for exercise. Show the functions, some relations defined by this, and now we have to find some images of the elements under that functions. So here is the two definition. Gx is equal to, when we use this definition, if x is greater than or equal to 2. And where we use this definition x plus 2 if x is strictly less than 2. So while finding f of 1, use this definition because 1 is less than 2. And while finding f of 5, we use this definition because uh, f of here is right, here is f notation, either here write g, right, here g, here g, and here g. So correction is in this problem, right, instead of f, g notation, because the given function notation is g. And then find by using these two definitions, f of 5, f of 1, for f of 1 use this definition, for f of 5 use first definition. Minus 2, again minus 2 is less than 2, so use this definition x plus 2. So then again range of the function, example on range of the function. This is find composition, formula to define composition. These examples are important as far as the exam concerned. Find formula for G circle F, find formula for G circle F, F circle G. Okay, here is also the examples. G circle G is what? Right, G circle G x is equal to G circle G of x. Then again G of x and G of x. That is multiplication, 3 time multiplication. Here is also the notation G. Here is G circle F x. This is G circle F x and F circle G x. So this is the example of test whether the function is injective, surjective, or both. So the first function is not injective. Find two elements in R such that their images are same. Similarly, these examples, solve these examples. So answers are given. This example, answers are given. So solve all the exercise examples.